Hello, is this working? Hey all, so I'm just enjoying a coffee from downstairs in my apartment complex. Just installed a coffee machine, and it's actually quite good. It rivals that of Phil's, which is a couple blocks away. Um, so I've been able to save $6 a day on coffee, so I'm pretty stoked. Um, anyway, so today's video is going to be on problem solving. So I find that problem solving is not taught in school. In fact, the very opposite. School psychologically trains you to be unable to solve problems. Well, they train you, they give you a mentality, they train you to have a mentality that is not conducive to solving problems. So basically, you're penalized for wrong answers. Um, and you don't get penalized without suffering a psychological penalty. So you go through years and years, 20 or more years, 2 decades worth roughly, of feeling penalized for wrong answers. Um, and that certainly makes sense for when there's a right answer that you should know off the top of your head. And I think a lot of contexts are like that. Um, so, but when you're solving problems, ones that are new, that don't have a solution that is forthcoming, then rather than regurgitating something from memory or from an established body of literature, you're going to have to go out looking for it. You're going to have to explore the problem space and sort of look for the solution. So what I found when I'm working with someone on problem solving technique, and in myself as well, especially early on in my journey, winning in problem solving feels bad. So the deliverables of problem solving are quite different from the deliverables of normal work. When you're problem solving, if you are able to, for example, come up with a counterexample for your approach, so a case or an instance in which a posited approach breaks down, and you're able to distill an insight from it, that's actually really good. You're winning, you're making progress. That is about as good as it gets. That's quite up there in terms of winning in terms of problem solving. However, people get demoralized when that happens. When people find that their approach doesn't work in some way, they should feel rewarded about it, but they don't. They feel demoralized and they want to stop going, and their motivation wanes. That is sort of the opposite mentality needed to solve problems, especially very hard ones. So I think it's important to recognize that. To recognize that on sort of a mass scale, we're training people to have a psychological state that prevents them from solving non-trivial problems that people have not solved before. So what does good problem solving look like? I think I just alluded to something, to some aspect of problem solving. One aspect is to what I just said, find a counterexample. It's actually a skill to look at an approach and think of ways to break it. In fact, that is actually a vehicle for deriving insights about a problem domain. So if you're able to find a counterexample and distill insights from that counterexample, you're winning. You're doing a really good job of problem solving. And rewinding before that, how did you get that approach that didn't work? Coming up with an approach is also success in problem solving, even if it's flawed. Because maybe the approach isn't the final answer, but it's a vehicle for exploring the problem. So being able to take an idea and fully develop it into an approach that can be validated or invalidated is good problem solving. It's part of problem solving. That's one of the things you have to do when you're solving a problem. To an even greater extreme, maybe your idea is sort of vague. It's not even, it's somewhat incoherent. It's just a vague feeling. It's like a hunch. Like your subconscious is telling you there's something here. There might not be, but that's what your subconscious / intuition is telling you. There's something here. Let's crystallize that hunch into a concrete approach that can be tested, that can be validated or invalidated. That is also a skill that needs to be worked on. The ability to take a hunch that you have that's pretty vague and then put in effort, sometimes quite a lot of effort, to crystallize it into a concrete approach that you can use as a vehicle to explore the problem domain by using it on a concrete example. And I guess I'm talking about like programming, but this sort of applies to other things as well. But just to keep things simple, I'm going to talk about coding, in particular coding challenges, some of the kind you might see on a website like LeetCode or Codeforces, or research, computer science research. That's also some place where you might use these techniques. So we've covered a few things. You have an approach, and you try it out on a concrete example, and you sort of try to break it. And if it's broken, then you've learned, with a bit more effort, you can take that breaking test case and you can articulate some insight or learning from that. So that was one thing we discussed. I just want to, a takeaway from that is that a counterexample is actually a deliverable in the course of problem solving. You've produced a deliverable. Also, the corresponding insight or observation is also deliverable. So we have 3 deliverables, 3 things that if you produce, you should feel quite rewarded by. So that would be the counterexample. You can add that to your test suite. Your insight or observation. So those are things you can add to the bank. You've made progress when you've discovered those things. Going back, if you were able to produce a concrete approach in the first place, that's also a deliverable. And going back even further than that, producing an idea that's incomplete, that needs to be fully developed, is also deliverable. And also, being able to sort of jot notes down about a hunch that you want to fully explore is also a deliverable. So those are good things. So that's just to summarize what we've covered so far. Going back even further, what if you don't have any hunches? If you don't have any hunches, there's nothing to explore. So the generation of ideas and hunches is the responsibility of your subconscious / intuition. So you can't really summon hunches and ideas on demand. What you can do, though, is you can produce stimuli and present it to your subconscious for the generation of hunches and ideas, and questions. So questions are also another deliverable. If you've raised a question, that's a deliverable. If you've answered the question, that's another one. So when you produce these things, you're making progress. So let's go back to crafting stimuli that will stimulate ideas and hunches. So typically, when I'm talking to even very experienced engineers, people feel very uncomfortable about being able to see patterns in uh, in, for example, phenomena that they're unfamiliar with. So, and that makes sense because you're often rewarded by really good pattern matching, like being able to recognize what techniques and so on apply to the current situation. So you can go really far just doing that. In order to derive insights, so if insights are critical to finding a solution to the problem, then that's a more daunting task. There's nothing you can read. You can't get trained up on it. You can't take like a class in order to learn how to solve this type of problem. You can't do those things. It's sort of more uncertain, and so it's very scary and daunting. So in order, you can't summon insights and hunches at will, but you can craft stimuli to stimulate the generation of these hunches and ideas, and that often comes from concrete examples. Are you able to think of concrete examples, and what are the different scenarios? Coming up with different scenarios are also deliverables in problem-solving process. So you can add another two classes of deliverables to your list of deliverables, things you should feel rewarded by when you're solving a problem. Those would be concrete examples, and also cases/scenarios. So often that alone will jog something in your brain, but if not, you can also take these concrete examples and walk through them using some concrete approach. And the approach doesn't actually have to be correct. It could be incorrect. It could be correct but inefficient. But by walking through the approach on concrete examples, and this is really important, using visualizations. So you have to think about how to visualize the problem in terms of diagrams. If you're unable to do so, it's sort of unlikely that you'll produce these insights. Often an insight is quite obvious if you're able to see what's going on. So a lot of problem solving is actually, and this might take some creativity actually, it's thinking of how to visualize your problem so that you can see, for example, in the case of programming, what the variables are, what they look like at certain steps of the approach, however flawed it might be, and so on. So if you're able to visualize it, things will jump out at you, and if they don't, there are a few things you can do. You can come up with more examples, bigger examples, smaller examples that depict different characteristics of the problem. You keep doing that, and the visual stimuli will stimulate ideas and hunches and so on for you to crystallize and develop into concrete approaches. And so that'll take you, some distance. It'll help you to make progress. There are other options as well. Another thing you can do, and Claude Shannon, the father of information theory, was very bullish on this technique. You can simplify the problem. You can remove complexities or make simplifying assumptions, relax constraints and so on to make the problem simpler in an attempt to distill the problem to its essentials. So you might be able to later on extend the solution to that problem, which was easier to solve, you might be able to extend it upon adding the complexities back in, Or you might also be able to use it as sort of a helper function or subproblem solution that you can use in service of solving the broader problem. So that is another technique that I'm able to think of at this moment. What are some others? So I think I covered concrete examples. Visuals are insanely important. If you're able to simplify the problem, that's truly excellent as well. I think another approach, if you're stuck, you can also take an approach that maybe isn't an exact fit for the problem, and think of ways to tweak it. Maybe you can iterate toward a solution by tweaking an existing solution. So, for example, let's say you're trying to solve a problem, and you think, okay, well, it's sort of a divide and conquer. It sort of indicates a divide and conquer approach, sort of similar to binary search. But binary search works on indices, whereas I don't have any indices here that I can use. How can I tweak binary search to fit this problem? And maybe you decide that you'll do binary search on a range as opposed to a range of indices, on just simply a range of numbers. And you know, it's actually quite well established that you can also do binary search on ranges of numbers as opposed to a specific array. It's sort of just an example, and you know, I'll try to think of a better one later. Anyway, I think these are the major hits of problem solving. I think if you're able to produce these things and you keep doing them, eventually you'll crack the problem. I think one of the main issues that I was trying to address was how demoralizing it can be for someone to try to crack a problem that you know, when things don't seem to be working right away. So it doesn't have to be that way. I don't think you're like that naturally. I think school and work and so on, all these competitions, they had a lot to do with your psychological training. And you can sort of, I believe that you can untrain yourself from that by recognizing when you're actually making progress and self-reinforcing that, providing reassurance to yourself. And I think a lot of problems are cracked that way. So it comes to mind right now, there's this guy named Ben Lin, and he was a PhD student at Stanford in cryptography. He was a senior engineer at Google for 10 years or so, and he recently went to work for a blockchain startup called Dfinity. But it's a great website. I learned Git from him pretty much, and one of his articles is about problem solving. It's called How I Solve It. And he mentions that he usually has some notion of how to attack a problem. And that's sort of a privilege that he has. I don't know what his techniques are, but I assume he gets stuck sometimes and he'll use a visual to jog something. But he says his issue is not that he doesn't have ideas, it's just that he doesn't feel like they'll work. He says it feels like that they're unlikely to work. But, you know, being someone from research, he's very familiar with this phenomenon, so his expectations are set accordingly. Basically, he knows they're unlikely to work, and they won't, probably, but by pursuing them anyway, he'll learn something about the problem, which will give rise to another idea. And you know, the same process will repeat itself. And he says eventually he cracks a problem that way. That sentiment is actually echoed by someone else from computer science. His name is Tim Roughgarden. He used to teach algorithms at Coursera. He's now a professor at Columbia. and I believe his field of research is game theory, algorithmic game theory. Um, so in his books, he has a new book series called Algorithms Illustrated or Illuminated or something like that. And in the back of each book, there's a problem-solving framework, and he says it's one of the steps. One of the steps, one of the heuristics he applies to problem solving, and I suggest you add this to your toolkit as well. He says, try all the greedy approaches that you can. And I assume he's talking about optimization problems. Even search problems. So this applies to optimization and search problems. Try all the greedy approaches that you can think of. He calls them all the natural greedy approaches, which I assume he means all the ones that come to mind. Greatest, least. Honestly, he also advocates choosing a random element, making a random choice. And he says in his book that it's unlikely to work, but think of small examples in which they fail, and the way in which they fail illuminate the problem. They allow you to derive or crystallize some insight about the problem that could lead you to coming up with the final, correct, optimal solution. So there you have it. Turns out they're both Stanford affiliated. What can I say? It's a great school, great institution. But yeah, don't be afraid of being wrong. Bad solutions, I like to say, are critical for finding good solutions. I think I should probably shut up now, finish my coffee, and go enjoy my Sunday. And I hope you guys do the same. Cheers from San Francisco, wherever you are in the world, and hit me up if you want to chat about anything. I'll also be live streaming some coding, so if you want to follow me on Twitch, I won't give you the Twitch username, but I'll just make it a puzzle. Go figure it out. I'll talk to you guys soon.